So let's start. Last week I was working on the threshold test, testology-based threshold test, and I noticed that the SeaStor detector complains when chromosome starts because it was reading the config file in the block using the blocking API. So I changed it to use the async IO. The asynchronized DMA file read offered by SeaStor to silence the warning, and I will wrap up the code review of the PR of the code review of a PR created by Sam in this week. That's me, Chen Mei.
I modified the external map tree PR according to Sam and Yinxin's comments, and the PR is updated. And still working on the old map tree layout operation currently. So that's all.
Sam?
Still working on dirty extent write-up. That's it. Hopefully I'll have a patch for at least that part this week. Or next week, possibly.
Thank you. Xuehan.
This week I was still working on the interruptible iterator feature, and right now I have replaced all SeaStor feature with the iterator feature along the I/O execution path. And right now I am working on the last phase, which is embedding the interrupt logic into iterator feature. And everything goes well, I think I should be able to submit the PR within the next several days. And that's all for me.
I'm just curious regarding to the performance regression. Did you get a chance to test out using to benchmark it with your change?
Yes, but I'm sorry that right now I don't have the data in my hand. I can send it in the email later.
No worries, thank you. Yinxin?
This week I have implemented and tested the cursor tracking facility with subtree management, and I'm looking at the SeaStor extend map implementations and trying to find a way to port the current memory-based solution to SeaStor. And that's me.
So you're starting working on the asynchronized owner tree, right?
Yeah. So I have some questions sent in email.
I just saw that. I'll try to reply you ASAP. Any further questions? No? Okay, thank you guys, and talk to you later. Go on.
Oh wait, I was muted the whole time. Sorry, Yingzhen. I'm looking at your thing right now. Do you want to talk about it now, or do you want to see it now?
Sure. I think we can talk about it.
I guess I'll also respond via email. For the first one, that should be safe, and I'll make a point of keeping it that way if you're going to use it. That seems valid and useful.
Mm-hmm. Do you think that we can remove the move constructor of the...
Yeah, I'm removing it now.
Okay.
I think that was a mistake on my part. I don't think I actually meant for it to be movable. It kind of defeats the purpose in a number of different ways. I see what you're going for there. Oh, it's because you wanted to use data members stashed in the cached extent itself, right? You want to make sure it doesn't move around?
Yeah.
Yeah, that's totally fair.
Yeah.
Best way to maintain the L editor.
The second tree is about where to store the logical address of the O node.
Honestly, for now, pick a well-known ladder number.
Like a magic number.
Okay. So
just pick a magic number. In real life, we probably want to think about how we wanted to use letters. So the larger, in one sense,
what if it is not static? Because according to my current implementation, the error address could be changed. Because I reuse one split, I reuse the original node and create the.
I see. You'd rather create a new one.
Yeah. So that may be
not
static.
You couldn't create a sort of a meta root, which just contains that pointer. Or we can find a way to refactor it so it fits into the root. That's fine with me too. It doesn't really matter to me. So, in other words, feel free to provide a patch that changes that root delta to add that piece of information as well. That's totally okay with me.
You mean in the root block data?
Yeah.
Okay.
I'm sort of ambivalent there. It doesn't seem fundamentally necessary, but it also seems kind of unnecessary to add this extra 4K extent whose only purpose in life is to point out your root. So both seem fine to me.
I don't get you. Why would you want to reallocate the root node with a different logic address?
This is the current implementation. When doing a split, the original node will be trimmed and the split node will be allocated, and the parent node will also be allocated as a new extent with a different.
By new, you mean a new logical extent?
Yeah.
I mean, you could just choose not to do that, but I'm okay with it either way.
Yeah, that's my.
The thing is,
I can also move
in real life. In real life, further along, we will need to think about what we want letters to be. So a couple of key questions, I think, are, is the letter space partitioned by core? 1. 2, do we want to add more bits to the letter to make it easy to use the bottom portions of the bits as for the object hash? That was my original intention. I assumed that when we allocate, this isn't really relevant for the O-node tree, but it's relevant for the extent map trees, the O-node trees, and the blocks themselves. When we want to go and allocate a data block for an object, we actually kind of want those data blocks to be close together in ladder in logical address space. That when we do metadata lookups in the LVA tree, we tend to get a lot of locality. We don't have to solve this now. I just wanted to point out that these are limitations that aren't actually solved with the current code. The code is left fairly flexible as to what letter actually is. I think I left it 64 bits, so we've got plenty of bits to work with. That's not really a problem. We just have to decide how we want to use them.
Yeah.
It's also possible that we... Oh, go ahead.
Sorry. I think this is also related to the M2M problem, right? Because if you assume that we need to support multiple cores...
Well, we do need to support multiple cores. We either do it with multiple processes or we don't, but we do need to support multiple cores.
I mean, we could use a single core for just a single instance of
yes, that would be the multi-process. That would be the multiple process technique for supporting multiple cores, but we will be supporting multiple cores.
With a
I'm going to point out that there's
a single process. I mean,
not necessarily. It might be multiple process, but one way or another, the setup system for Crimson will ensure that we make use of all of the cores. If that's multiple Crimson OSDs, fine. But one way or another, that's our problem. We do have to make it work. I will point out that one process per core probably isn't a good idea. Because for like a 128 core machine, we probably don't want 128 SeaStor instances. That seems unlikely to me. That would be a lot. And core counts are only going to go up from here. They're not going to go down. So I suspect that that technique is probably impossible on its own. We would need some way of multiplexing multiple threads onto one SeaStor instance. In general.
Yes,
I'm ambivalent. I'm open as to what that is, but I do want to call that out. I don't think it's possible that we will have one SeaStor instance per thread. I think there will be a crossbar, at least on some configurations. And the other half is, if we do try to support 128 SeaStor instances because the device really does have that much throughput, or that much parallelism, then we will need a way of moving free space among them. So they can't be completely partitioned. we'd very likely end up with a lot of orphan space from uneven partitioning. So while it's possible that a lot of the
I'm not quite on
OSD,
board with you regarding to multi.
it's a two-part argument. The first is that I don't think it's likely we'll see a lot of devices with 128 independent threads of parallelism. I mean, the actual NVMe device is part one. Part two is that even if we did, that means we have to partition the device into 128 individual pieces. If we do that statically, we will get orphan space, for sure, which will be bad. So we will want the SeaStor instances to be able to share PGs among them. So regardless of how we go about this, SeaStor itself has to be able to move data between SeaStor instances without a ginormous amount of overhead. And part of that might involve a shared L address space. So we'll have to think about this with some care. You see what I mean?
Yes, I have two arguments. One is I'm not quite sure regarding to the 128 Crimson process necessary bad thing, but I agree with you regarding to partitioning a fast NVMe device into like 128.
Yeah, one way or another, we have to be able to share space.
That's a
coarse
a
grain
lot of internal fragments, and it will be big pain in future. So,
not just a big pain. It's not that it's a pain. It's that will cause orphan space. So if you take anything and divide it into 128 pieces, and then you assign a uniform distribution of objects among those partitions, you will get lesser and more used shards. You will need to even out that distribution, and that can't be expensive because it's going to happen a lot. So those 128 SeaStor instances, if they really do exist, will need a way to cheaply reassign data without necessarily doing a lot of moves.
TC-malloc approach to move the free space around.
Because this is a storage system. It means that when we want to move things around, we need a way to not necessarily move literally all of the bytes. We would like to move just the metadata trees if possible. Whereas the actual space would get moved but not really moved, would just get reassigned. So for that reason, we would want things like the LBA tree or like all of the extents associated with a particular object or PG, we would want to be able to quickly and efficiently pick out of one SeaStor instance and put into another without actually necessarily copying all of it. This is a problem we're going to have to solve at some point.
You'll be sharing the same LBA tree instance.
No, it definitely won't be sharing the same LBA tree instance because that would be a giant concurrency point, which would be bad. But we could statically partition up the 64 bits we have available to us for logical address space so that none of the cores collide on logical addresses. Like, there are a lot of techniques here. It's just that we may want to be careful with how we use logical addresses so that later we find a cheap way to move things around. Because we definitely can't have one SeaStor instance for the whole thing, at least on some coarse level, because we can only do transactions on one SeaStor instance. And we want to be able to serve a lot of transactions concurrently. So we need a coarse-grained, expensive way of moving things between cores that isn't very expensive. So this is a digression. I'm just saying I wanted to point out that the way we're currently using logical addresses is naive, and we will want to do something more clever in the future. That's why the LBA tree interface has a way of asking for a hint for which ladder you want to start at when looking for free space. In other words, Yingzhen, I'm ambivalent as to how we do this for now, just because I think it's going to become more complicated in the future, and we'll have to think this through. So if we want to stick in the root block for now, totally okay with me. I will point out, however, that, actually, is the O node the only logical root? Are there any other logical roots? Like, every query starts in the O node tree, right? Every extent in the entire system that isn't part of the LBA tree is accessible via the O node tree, right?
Yes.
Okay, so that's the only root, so we can just stick it in the root block. It's fine. It's not going to grow. We're not going to have like 3 of these. Yeah.
So we can piggyback it in header of the segment, right?
Yeah. Concretely, what you're going to do is you're going to add an interface to Transaction Manager that allows you to set or update the logical root address. And then the Transaction Manager will plumb that through to the root block.
So,
Mhm.
so in other way, we could make it an exception, just like we did in regarding to the LBA route.
An extension, sorry? No, I think we're just going to stash all of it in the same root block. There's no reason to add another one. I think. You could add another one. Like you could have a logical root whose only purpose is, which is at like a well-known logical address, whose only purpose is to track the root of the onode tree or any other logical roots we create. But since there's only going to be one of them, I'm inclined to just stick it in the root block. Like we can add one chunky interface to Transaction Manager to just shove this piece of information through. It's no big deal.
Okay, I get it. I think.
Okay, I need to go through think through it a little bit more. Anything else?
I think there's a third question about the cache eviction. So is there any plans to implement it in the cache layer?
Yeah, that's the idea. That's what I'm writing right now, actually.
Okay,
so
okay.
the first step is I'm going to write dirty block write out because you just have to have that so you can trim the journal.
Mm-hmm.
That the actual logic for doing rewrites will be identical then for any extent. Oh, actually, well, for regular extents, you can just evict for free, right? The only constraint being that we can't evict anything that's the parent of a cached node, not in the onode sense, in the LBA sense. So once I add cache pressure, I think I'm just going to dump them. Do you need some kind of feedback or information, pinning, something like that?
So I'm not quite follow. Why do I need the ping or the ping?
I'm just asking if you do. If you don't need any pinning, then I'm just not going to send notifications of that sort of event. You won't be able to see it anyway.
Currently I don't think any requirement about pinning.
Cool. So what it'll look like is...
I think it could be helpful.
Well, there'll be debugging output, but I'm not going to add an interface unless there's a user for it.
Okay, do you mean that logical extent can be evicted at any time?
As long as you're not in the middle of a transaction, yeah. So as long as you hold a reference to an extent you're allowed to hold a reference to, it won't be evicted.
Mm-hmm. Okay.
The corollary to that is don't hold a bunch of extent references and definitely don't hold them after the transaction is over. But as long as that, you'll never lose an extent. The memory will not become invalid while you're looking at it. Oh, sorry, it actually can. You don't need to worry about this too much. It'll just cause your transaction to fail if it happens concurrently. But it is possible that another transaction will invalidate one of your extents while you're using it. But the cache won't evict it because it'll be pinned implicitly by the fact that your transaction holds a reference to it. Does that make sense?
I think so, but I will keep looking at it.
In other words, if there's a concurrent transaction going and it writes to one of the extents you've read, you will still see the copy of the extent, assuming I've done this correctly, you'll still see the copy of the extent you originally read, but it'll be invalid. It'll be marked as status invalid. It's still safe to mess with it. It's just yeah. If you notice, you're free to fail the transaction yourself and just fail. If you don't notice, submit transaction will fail it for you. You'll get an error.
Okay. Oh, okay. Okay.
But you don't have to worry about. Oh, okay. But you don't have to worry about eviction of an extent you are using. Holding the reference to it will hold it in cache.
As long as I hold the reference of the extent.
Right.
Okay.
I think I actually got a question for you. So you keep track of the parent nodes when you walk down to a leaf node, right, in an O-node chain.
Yeah.
That's why you don't need to the pin machinery offered in the layer. Okay.
Like if we do need to add some kind of pinning, we can do that. We'll just have to figure out how. I'd like not to if we can avoid it though.
Yes. I'm thinking about it if it would give me some advantage regarding to doing it by myself.
Hypothetically, but it would require it would require changes to the transaction manager layer. Just because the reference you're holding can change under you. So you can't actually hold a reference to pin it. We would need to add a separate system for that. Or like it would be more like mark pinned on the extent or something. Holding the reference wouldn't be enough. But let's not discuss that until we actually need it. It's possible that just a conventional LRU scheme will just do the job, in which case, great. Like anything near the top of the tree is naturally going to stay near the top of the LRU once they get around to implementing it. Because every read traversal will always start by reading it. Which is normally what you'd want to pin anyway. You'd want to pin stuff near the top of the tree. The reason for the LBA pinning essentially is so that that sort of approach to logical extents has the right outcome.
Okay, I think I have another question. What's the typical usage if to increase the reference count of the extent to more
clones.
than one?
That's
only
okay.
clones,
So
right?
it's worth talking about that. That does not refer to in-memory ref counting. That refers to on-disk ref counting. So if multiple objects are cloned off of the same original object, they'll share extents.
So currently we need to worry about it.
We'll need to worry about it later when we go to implement clone. The LBA tree knows what to do. It maintains a ref count in the LBA node. So that's all handled at a low level. It's just that when we actually go and implement clone, it'll be something like maybe the extent map itself, all of its internal trees, nodes. You'll just like both object O nodes will have a reference to the root of that with an incremented ref count. And then you'd have to make a point of copying and decrementing it every time that happens. Does that make sense?
So as a user, we don't directly increase the reference by ourselves. It is.
You would if you were implementing clone.
Clone.
Yeah. So let's say
Yes.
we're cloning an object. You create a new O node for the new object. Then maybe the extent map root, you just point directly at the very same extent map root. And then you'd increment its ref count. So those two objects share the same object contents. Then every time you mutate it, the natural operations on the extent map, anytime you need to change something internally, you'd copy it and then decref it. And we'd have to go to some effort to make sure this actually works correctly. There is work that would have to be done at that level, but at least the LBA tree would know what the ref counts are. That way you don't have to store them alongside the blocks or something. That'd be really expensive. Do you see what I mean?
Yeah.
Cool. Perhaps I shouldn't have called it incref and decref. It didn't occur to me that that would collide with the verbs for like memory operations. But that's what I meant.
Thank you, Sam.
Sure.
Any other questions? No?
All right. Talk to you later. Bye.
Okay, talk to you later.
Yeah.
Have a good one. Bye.